I did post a bunch of stuff also on YouTube and Blackboard. Okay, just letting you know, like notes and stuff and videos. All right. Okay, so this is just some review I wanted to do. Okay, so here we have a system of equations, and again, with a system of equations, remember, in a sense, you really only have two methods, even though I showed you three. We have elimination, substitution, and we have decimals. Okay? Those are the two that we have. Those are the three that we have. But really, in the exam, well, for the exam, I'll tell you which methods you can use. Okay? And you have to use whatever I tell you to use. So, just letting you know. Generally, with Desmos, you can use that to check, with the system of equations. You can graph it, and that's actually something I recommend you do. But pretty much, you're only going to be able to use elimination or substitution to solve it. Okay. Okay, so let's solve this system. Okay, now, what I'm going to do is use elimination. What I'm going to do, though, is for x, right? Notice that we have a half here, and we have 2x over here. What I can do, though, is I can multiply the first equation by -4, right? And if I do that, the 1 over 2 becomes -2. And then, of course, you can add it to the second equation. I mean, do you have to do that exactly? No. You could eliminate y. You would just have to multiply the first equation by something and the second equation by something else. So I figured also by eliminating x, you would essentially eliminate this fraction. Okay. Excuse me. So I multiplied both sides by -4. Right? And what do we get? Well, after we distribute, we get let me draw that in. After we distribute, okay, we get -4 times 1 over 2 times x plus -4 times 2y is -4 times 9. So here we get -2 times x, right? Because -4 times a half is -2. Here we have -8y and we have -36. So really what we're doing is we're replacing the first equation with this one, and we get this, and we can add that to the second equation, right? This is this is the equation we just had. Here, it was plus negative. I changed it to subtraction. It's really the same thing. We're going to add that to the second equation. And now, is that helpful? Well, yeah, it's going to be helpful because, as you can see, the two x's are going to vanish. The x is going to go away. That's why there's nothing here. So when you add the equations, right, the x's are gone, as you can see. And here we get -8y, we have -3y. We add those, you get -11y. And -36 plus 14 is -22, as you can see. So essentially we killed off x. We only have one variable, y, and we can solve that. Right? Namely, what do? Well, we have one equation with one unknown. We just solve that. I mean, here it's easy because you have -11y equals -22. So what do? You just divide both sides by -11, as you can see. You divide, and it's gone, right? You divide by -11, you get y equals 2. Right? You get y equals 2. So we know what y is, but we're not done, right? We want to get x. How do we do that? Well, we could take the y we have, plug it in to either equation. I plugged it into the second. I mean, if you plug into the first, that's fine, but then you have a fraction to deal with. Plug it into the second. And now we have an equation then in only x. 14 equals 2x minus 6. That's what we get. Okay? So because of that, we have 2x minus 6 equals 14. Now, what do we do next? Well, we want to solve for x. Let's isolate it. We add 6 to both sides, right? We get 2x equals 20. 2x equals 20. Divide both sides by 2 because we don't want 2x, we want x. So we get the 2 out of there by dividing, and we get x equals 10. So x is 10, y is 2. That's our only solution, as you can see. That's the only solution, 10, 2. Okay, I'm also going to solve this another way, just in case people like substitution better. But are there any questions on this, though? Okay. All right. So here, let's say instead we decided to use substitution. Remember, in substitution, you want to get one variable in terms of the other. That's the way you kill off a variable, so to say. So here, notice, I'm going to take the first equation. We have a half times x plus 2y is 9. But we can easily get x in terms of y, right? Let's subtract 2y from both sides. And we get 1 over 2 times x is 9 minus 2y. I mean, I thought to do it this way because if I do this, I can kill off the fraction. How do I do that? I multiply both sides by 2. So multiplying both sides by 2, right? You can see what happens here. The 2 times a half cancel, we get x. I distribute the 2. So we have 2 times 1 over 2 times x is 2 times 9 minus 2 times 2y. Okay? And so we get x equals 18 minus 4y. That's what we get here. So again, I just multiplied both sides by 2 because I want the 1 over 2 to go away. Okay? And what you do to one side, you do to the other. So we distribute, right? Multiply by 2, and then we distribute. We get x equals 18 minus 18 minus 4y. Lost my train of thought. And so now we know what x is in terms of y. What do you do next? You use the other equation. How do we use it? You replace x by this. That's what we do. That's what we do. Okay, so we substitute, right? That's what I did over here. 2x, 2 times 18 minus 4y. And of course, we can simplify that a bit. We distribute the 2. We get 2 times 18 is 36. Minus 2 times 4y is 8y. Minus 3y is 14. As you can see. Right, so again, I distribute. Yeah, let me draw it in. That might be better. Distribute, right? You get 2 times 18 minus 2 times 4y minus 3y. And that's 36 minus 8y minus 3y, which is 14. So we get 36 minus 11y is 14. And now we have one equation, one unknown. We can solve for that, right? And that's what I'm doing. I'm isolating y. I'm solving for y. So we have 36 minus 11y is 14. We subtract 36 from both sides, and we get negative 11y equals negative 22. And so we divide by negative 11 because we want y to be all alone. We get y equals 2. Okay, y equals 2. Now, since y equals 2, we can get x. How do we do that? We can use this. Or really, I guess we could plug this y into either of the equations, or we can just use this. Right? We have x equals 18 minus 4y. So for y equal to 2, we get 18 minus 4 times 2, which is 18 minus 8, which is 10. So our only solution is x equals 10, y equals 2, so we have this ordered pair, as you can see. All right, that's good, good, good. All right, any questions on that? Okay. We also can check here by graphing in Desmos. That's what I did, right? You know, I graphed each one on a line. I graphed each of these lines, and we got the 2 lines here. In fact, let me show that. I feel better. I mean, I wasn't planning on showing it in Desmos, but what the heck? Stop this. Right? So again, in Desmos, which I encourage you to use, you know, you can use it to check. Math tools, graphing calculator. So we have a half times x plus 2y equals 9, right? So I'm graphing the first equation. Now for the second one, okay, 2x minus 3y is 14. Now, of course, it's hard to see, so we have to move over a bit, click and drag, and there is an intersection point, and we see it here, 10, 2. So, good way to check our result. Are there any questions on this? Okay, so let me stop sharing this.